Well, good morning, Meng. Welcome to ISHI 35.
Good morning.
Nice
My
to
pleasure.
meet you.
Pleased to meet you.
So what brought you here to ISHI 35 this year? You did a presentation, correct?
Yes, I did a presentation on applying AI to DNA profile analysis. So yeah, that was the main reason for being here, and also just to learn from everyone else in the community.
Yeah. Is this your first ISHI?
This is my first ISHI. Finally made it, so it's been great. Yeah.
How long have you been interested in the AI portion of genetic research?
It all started about maybe 5-6 years ago. I was working on a product that our team is developing, FaSTR DNA analysis software.
Okay.
And through that development, one of our developers, Duncan Taylor, so he was authoring some innovative thinking in the AI space and how that could be used for DNA profiling. So we picked that up through all of our development, and here we are. Yeah.
So what are you using as your AI? Is this an in-house AI, or are you using a publicly available AI system?
Yeah, this is an in-house AI system,
Okay.
again based on Dr. Taylor's publications, his creation, and we've implemented it. I mean, we work quite closely with him, so he's one of the original developers of FaSTR DNA, the probabilistic genotyping software. So
Okay.
another innovation he produced was the AI. So we implemented that, and yes, fully in-house. We train it in-house as well. Yeah.
So what have you found? What are the benefits?
The benefits of using that, I mean, I just want to also define the AI. AI seems like a misnomer, right? To us, it's a misnomer because the implying that it has any intelligence is inaccurate, right? So it is a trained algorithm.
Okay.
It's more complex than our standard algorithms that we're used to. However, as a trained algorithm, we direct how it performs and we assess how it performs. But having said that, so with this advanced algorithm, we apply it in DNA profile classification. So this is where we use it to help us determine the nature of different signals within the profile.
Okay, so let's say this was utilized and then it was brought to a case. Would that be utilized in court? Would that have to be explained, let's say, during a proceeding?
I think as with anything, if it's innovative, we understand that a full explanation is beneficial for understanding and usage. The great thing about this implementation of the AI, or the neural network, we sometimes call it, it's fully published research, and it's fully published and developmentally validated. So the performance and everything of how it works is actually published and traceable. Yeah. So I mean that is always what we aim for as well. The quality, the transparency, the publication, the how we can explain it. Yeah, that's all available.
So this is also a product, right? So
Correct.
some of these labs can purchase that, correct?
Yes. So this product is implemented. This is implemented in our analysis software product called FaSTR DNA, and this is one of the currently 4 software products available from StarMix, which is a part of ISHI, which is a government laboratory actually. So
Really?
so we are effectively public servants working in a department which happens to produce software products that the community uses. Yeah.
Okay, so who would be utilizing this product? Is it small labs, big labs? Who has been customers of this?
So customers of FaSTR DNA, the product itself, is anyone who uses analysis software.
Okay.
So basically every laboratory that does DNA analysis would use FaSTR DNA. I mean, it's at the first stage of the DNA interpretation workflow. So you go from analysis. So you go from the lab, you produce the raw data from the instruments, and the first step you take is you put it into analysis software. This software creates the images of the DNA profiles that we see in these, in either in
CSI.
TV or
Yeah, it just
CSI
prints out a picture of the
or
person's face,
presentations.
right?
Yeah, and then
It's
there's
just the guy that did it.
there's these things, right? So our software, FaSTR DNA, does this first step.
Okay.
Then if we extend the full workflow, it's a fully integrated system where, you know how things, when it just works, when one software goes to the next one,
yeah.
because you don't need to fiddle around with anything in between. That's how our workflow works. So we take the analyzed profile, you send it to StarMix for further interpretation. So, you're looking at things like the likely contributors and, how the mixture looks and everything like that. And then we can extend this even further with our other software, DBLR. So this lets you investigate further information captured within those samples.
That's amazing. So at this company, what is your job? What do you do on a day-to-day basis?
It's quite varied.
Okay.
There's a
That's fun.
there's a broad range. I'm a scientist by training.
Okay.
I'm a scientist at heart. So a lot of my role is technically related. Myself, I'm responsible for the scientific component of FaSTR DNA, the software. So this is development, scientific enhancement, test and validation, and also support to our customers. Because at StarMix, we believe that the quality is always the most important. And if we're supporting our peers effectively, we are scientists ourselves, we would hope that we produce and we provide the highest level of support to our peers, because we know that's what's needed. You don't need a tech support, to answer those types of questions. You need a real scientist to answer questions.
Support. Yeah.
Yes.
Yeah, that's really cool. I was just thinking about this program. Does it talk to all of the genetic genealogy type programs that are out
No,
there
it
as well?
doesn't.
It
So,
doesn't
so
talk to
our
that.
software doesn't do genealogy.
Okay,
Yeah.
it doesn't do
Yeah.
that. Is that a future endeavor?
That
be
is
something to-
a future thinking.
Yeah.
The step to take for that is how do we produce our data outputs in a sensible way that informs genealogy. You can see some components of that in our outputs, and especially in DBLR, our investigative software. Within that software, it's a very cool analysis you can do. It is kinship scenarios.
Okay.
You can propose different kinship scenarios and calculate a likelihood ratio to this. So you could say, for example, a very simple example is a missing persons case. So you have a mixture sample, unknown person. You suspect whether or not your missing person could be a contributor in that sample, because you're trying to find your missing person. You have an evidence item. So in DBLR, you can set up different propositions. You can set up one proposition where you say you have two parents and a child. The child is the missing person. And you can say, or the alternative is, this is just the unrelated person, so it's not the missing person.
Sure.
You can set up these two tests, test them against one another, and generate a likelihood ratio, which will inform you as to the likelihood of each scenario.
Yeah, so it's kind of already thinking.
We're thinking along those lines. I will not say that it does genealogy, because it doesn't.
Sure.
It will be a further step to configure the outputs to be compatible and informative for that.
Yeah. So you're very passionate about this. When did you get into this world? When did you start this process?
Well,
for yourself?
It's not been a linear path.
Okay.
So, when you're growing up, I studied science in high school, in university. I got very, very interested in biotechnology, especially genetics, molecular genetics. So with that as a foundation, I did research studies during university based in molecular biology and genetics. I will say it wasn't forensic particularly.
Sure.
However, thinking back now, that was a very, very strong fundamental skill, because forensic biology is anchored in molecular genetics. So that, fortunately for me, that was cross-transferable, and since working in the forensic field, that's the natural progression. So I think the passion for this type of highly technical work has always been there, And I think my interest has shifted to forensic because it's a very interesting area to work in as well. Yeah.
What do you think of this ISHI community of all these forensics people coming together?
Yeah, I think it's great. I think it's somewhat different to outside of a forensic scientific community.
Yeah.
I find that because I've been in both worlds, I find that the general scientific community, and especially the research community, can be quite competitive.
Yeah.
And with that competition, I won't say anything too extreme, but there is a natural difference in interaction.
Yeah.
I love the forensic community because everyone has a very strong purpose. There's a very real purpose of why we do the work that we do, and that fuels from our team, our perspective, it fuels the motivation to deliver the utmost quality because we know the importance of it. We understand the importance because a lot of us are the practitioners anyway. We understand what's required of this. So yeah, I guess the interest has always been there.
That's great. Yeah, I feel like in that forensics community, it's a real people helping people
Yes.
kind of feel,
Yes.
right? Because you all do have that main focus of helping people, right? Like
Exactly.
the families or the victim.
Exactly.
Or exonerating somebody,
Yes.
all of those things. Everyone has a common goal.
Yes.
So it's very, very interesting. So thanks a lot for coming and chatting with me today. Are you going to come back to ISHI 36?
I hope so.
I hope you
that
do
will
too.
be the aim. Yes.
All right.
Thank you
Thanks
very
so much for chatting with me.
Thank you.
Nice
Pleasure.
meeting you.